Hello, my name is Kaya Mitchell, and today I'll be presenting my Lab 1. Introduction. Coulomb's law states that the electric force between two charged objects is directly proportional to the charge of the objects and inversely proportional to the distance squared between the two objects. The electric force between two objects is a non-contact force which acts over a separation of distance. In this lab, we will examine, model, and apply Coulomb's law in order to determine the charge, number of excess electrons, and fraction of electron-deficient atoms on one piece of tape. To do this, we will also apply Newton's second law, which states that the acceleration of the object is dependent upon the net force acting on the object and the mass of the object. In this case, the two forces that will be acting on our model is the gravitational force expressed by the weight of an object and the electric force. The methodology used in this experimentation was as follows. We created two charged pieces of tape by placing one tape on top of another and quickly pulling them apart from each other. We then oriented the two charged pieces of tape so that one hovers over the other. Next, we recorded the separation distance between the two charged pieces of tape in order to calculate the charge of the floating piece of tape. And finally, we constructed a computational model of this interaction using GlowScript. In order to approximate the answers we saw in performing this lab, we made the simplifying assumptions that both pieces of tape have the same charge, no air resistance was acting on the tape when it was hovering, and finally, we treated the hovering pieces of tape as a point particle. Before performing the actual experiment for the lab, we first had to determine the net charge on one piece of tape. To do this, we observed the tape interacting with different objects. From my observations, I found that the tape was attracted to my hand, it did not interact with the neutral table, it was attracted to a negatively charged pin, and it repelled another piece of charged tape. And from these observations, I was able to conclude that the tape was positively charged. I then went on to set some initial conditions in my lab code where I inputted the physical constants that would be needed in calculation, including the length of an atom and the charge of an electron, and the initial values, which I will show in the next slide, which is as shows is the length of one piece of tape that we use, the mass of the tape, which I'll show how we found, the width of the tape, and the distance between the two charged pieces of tape, and right here the objects that I called for tape A and tape B. In order to calculate the mass of tape, I multiplied the length of the tape times 1 gram divided by 1 meter, and it gave us this value for mass right here. The force of gravity was found by multiplying the mass times the gravitational constant, which gave us this force right here, and the separation distance was what I recorded when performing the lab. And since air resistance is not acting in this model, we had that the force of gravity is equal to electric force, and therefore mass times gravity is equal to the electric force, and we use this to find the charge of the floating piece of tape, which was this value right here. I then found the surface area of the tape by multiplying the length times width. The number of atoms of the tape was found by dividing the surface area by the area of atoms. The axis of electrons was found by taking the charge of the tape and dividing it by the charge of the electron. And the ratio of the axis of electrons was axis of electrons that was lost to the atoms was found by dividing the axis of electrons by the number of atoms. And then here, after making these calculations, I then put this into my computational code in order to visually represent the information I had calculated on hand. Right here is the force of gravity and electric force vector, and right here are the calculations that I showed in the previous slide. And in our results, we were able to find that the computational model representation successfully modeled the observed data made during the experimentation. Through completion of this lab, we found that the charge of the tape was 4.67 times 10 to the negative 9 coulombs, and the ratio between excess electrons to the number of atoms was 14.46, and the other values were found under here. The follow-up questions to the lab were as follow. I said that if the electrons had positive charge and the protons had a negative charge, the interaction between the two pieces of tape would still repel each other, being that they would continue to have the same sign. However, the tape's interaction with all other objects would reverse, whereas if it were attracted to an object, it would then be repelled and vice versa. And I said that it's important to handle the two charged pieces of tape as little as possible, because when the charged tape interacts with your hand, your negatively charged hand begins to distribute some of its charge to the positively charged tape, making the tape become more neutral and uncharged, and therefore affecting the results to your lab. Thank you so much for learning physics with me, and I hope to see you next time. Bye!